Hello everyone, this is Anita Arshatter, Associate Professor in Physics, working at RR Institute of Technology, Bangalore. Today in this video, we are going to see one of the experiment prescribed in the force engineering physics laboratory, that is Fermi energy. The aim of the experiment is to determine the Fermi energy of a given copper coil. The formula to calculate Fermi energy of a given metal is given by EF is equal to 1.437 into 10 to the power of minus 15 multiplied by square root of A rho S divided by L. And this will be in joule. In order to convert electron volt, I just divide it by 1.6 into 10 to the power of minus 19, where A is the area of cross section of copper wire, and area can be calculated using formula pi d square by 4, where d is the diameter of the copper wire. In our laboratory we have a diameter 0.5 millimeter, that is 0.5 into 10 to the power of minus 3 meter, and density of the copper is 8693 kg per meter cube. In our laboratory, the length of the copper wire which we have used is 3.6 meter, and S is the slope obtained after the experiment and plotting a graph of variation of resistance with respect to temperature. As the temperature increases, the resistance increases linearly. So this is the graph we expect, and the slope is just a triangle on this line. So the slope is nothing but delta R by delta T. Let us see how to do the connections.
So this is the position of the coil. So positive of the battery must go to the one end of the coil. The other end of the coil must go to the negative of the milliammeter. So other end of the coil has gone to the negative of the, sorry, it should go to the positive. Next, from the negative, it should go to the negative of the battery. Next, we have left out with two wires. One is from positive of battery, another is from the positive of the negative of the voltmeter. So these two must go to the across the copper wire in such a way that where the positive has come. So this is positive wire, this has come here. So for that the positive of the voltmeter should go, and this one should go to the negative of voltmeter. So this is the connection.
Let us see how to conduct
The
experiment
temperature.
to determine Fermi energy of
So we will start with the
copper
85
coil.
degree. Then corresponding voltage and current has to be noted. Now it is at 83. So for 83, okay, we'll start with 80. When it comes to 80 degree, we have to note down the voltage and current. So now it is 80 degree. For 80 degree, the voltage is 31.6 millivolt and the current is 97.2 milliamp. Next we have to wait till it cool by 5 degree. After it reaches 75 degree, again we have to note down the current and voltage. Likewise, we decrease by 5 degree till 60 and note down the corresponding voltage and current. Now it is 78. It is 76. Now you can see the temperature is 75 degree Celsius. For 75 degree Celsius, we have to note down the corresponding voltage and temperature. It is 31.1 millivolt and the current is 97.2. It is 72 now. Now it came to 70 degree. So for 70 degree, note down the 31.1 and this is 97.
Like this, we can note down.
Another two readings we have to take, 65 degree Celsius and 60 degree Celsius.
Similarly, we have to note down for 65 degree voltage and current, and for 60 degree also voltage and current. So that comes out to be
Now it is at 67. Now it has come to 65 degree. So for 65 degree, note down corresponding voltage and current. It is 30.4 and that is 97.3. Another last reading we have to take when it reaches 60 degrees Celsius. If you start from 85, 65 you can stop, but the highest temperature now it was achieved is 83. So I could not take 85, so I will go up to 60 degree. When it reaches 60, it is near to 60. Yes, it reached 60. So note down corresponding voltage and current. It is 29.8 and this is 97.4.
Here is the nature of graph showing the variation of resistance with respect to temperature. We have done an experiment, so we have calculated the resistance for corresponding temperatures, and let us plot a graph of temperature versus resistance. So we get a straight line. I have to take a slope. Anywhere you can choose. I will choose these 2 points because for me it's easy to do calculations. We call this, I call it as B, this I call it as C. So slope is nothing but AB by BC. You can see the reading of A is 0.325 and B reading is 0.306. The difference of them gives AB. A reading minus B reading. The difference gives you AB. The difference here it comes out to be 0. I hope you understand this. How do we got this? 0.325 minus 0.306 divided by BC, the reading of B minus reading of C. The reading of B is 353. 353 minus reading of C is 333. If we calculate this, the difference comes out to be 0.019 divided by 20. So answer is 9.5 into 10 to the power of minus 4. So this is the slope. Let us calculate Fermi energy. Before substituting here, let us first find out the area of cross section. A is equal to pi d square by 4. Pi is 3.142. 3.142 multiplied by d square. D means 0.5 square. 0.5 square, and it is minus 3 is there, so square of that 10 to the power of minus 6, this divided by 4. If you calculate this, the answer is 0.1964. 1964 into 10 to the power of minus 6 meter square. Okay, so let me consider this factor and calculate here. Let us consider square root of here is a mistake. This is under square root of A rho S by L. A rho S divided by L. So A is the area, already we have calculated. This is all under square root 0.1964 into 10 to the power of minus 6. Rho is the density, which is 8693 multiplied by slope. Slope already we have calculated, which comes out to be 9.5 into 10 to the power of 9.5 into 10 to the power of minus 4 divided by 3.6. Length is 3.6. So substitute it. The answer comes out to be for this at 6.7 into 10 to the power of minus 4. Okay, now let us calculate this. So 1.437 as it is I am writing into 10 to the power of minus 15. And this factor we have calculated, which is 6.7 into 10 to the power of minus 4 divided by 1.6 into 10 to the power of minus 19. Here minus 15 minus 4 is 19. That gets cancelled with the denominator. So the product of 1.437 and 6.7 comes out to be 9.645. 9.645 divided by 1.6. The answer comes to be 6.03 electron. Hence, the Fermi energy of given copper coil is found to be 6.03 electron volt. So, Dear students, answer these questions. What is Fermi energy? What do you mean by Fermi energy of a given copper coil is 6 electron volt? What happens to the value of Fermi energy if we change the length of copper wire used? What happens to the value of Fermi energy if we change diameter of the copper wire? Does Fermi energy is a constant for all metals? Justify your answer. I hope you understood how to perform an experiment to determine Fermi energy of a given metal. Thank you.